Hi, I'm Phil Richards. I'm the course director for the biomedical engineering degree at the University of Strathclyde, and I'm here to say thank you very much for applying for one of the programs to come from the Department of Biomedical Engineering. I would like to give you a little bit more information on what you might expect when you eventually choose us and arrive in the coming year. So what I want to do is to give you a little bit of a PowerPoint presentation, and then my contact details at the end, and you can always email me any follow-up questions. So let me go to the PowerPoint presentation. Okay, hopefully you can see that clearly now. So your applicants, you either apply for the biomedical engineering degree or the prosthetics and orthotics degree. Now, I'm sure you know all about biomedical engineering and prosthetics and orthotics and what the two differences are, so I won't bore you with that. But what I wanted to highlight was the pictures at the bottom of this slide, is that many people in terms of biomedical engineering think it's quite a relatively new field, but the bioengineering, as it was back in the day when I studied it, it's been going on at Strathclyde since 1963. Okay, and this picture here on the bottom left is our building, our purpose-built Department of Biomedical Engineering, and that was built in 1972. And these pictures are from the early 1970s. We have been doing biomedical engineering at the University of Strathclyde nearly, or longer than nearly anywhere else in the world. Okay, there's very few places that can equal us for our history, our number of graduates that over that period of time that we've managed to pump out. These graduates are in positions of authority around the world, and wherever you go in the field, people know and have heard about Strathclyde in a very positive way. At that same time, at the early 1970s, the National Centre for Prosthetics and Orthotics was also founded, and that has been graduating prosthetists and orthotists, one of only two programs in the UK that can graduate prosthetists and orthotists, and we've been doing it again longer than the other one. So without further ado, to introduce the programs in our department a little bit more, I'll go to the next slide and we'll start off with the video. Hopefully it will work.
Biomedical engineering is the maintenance of the health of society.
It's the link between technology and medicine.
It's not just about knowledge, it's about coming up with a device that could help people and patients.
Here at the University of Strathclyde, we focus primarily on developing technologies, devices and techniques that will make a difference and will impact on global healthcare needs.
If you don't have access to an actual full-scale hospital, you can have point-of-care elements that you can take out into the field and use and treat people who might not be able to be treated.
Increase the quality of life for people that are suffering from problems like hip replacements. They're trying to make them lighter, more durable, cardiac devices, reduce the need for transplants, really to help people in the easiest and most cost-effective way.
We're really working, I think, in many levels at the cutting edge of medical technology. We're working with the military to develop a new form of blood salvage system for deployment in the battlefield. We have a group who've developed the PEAK technology. That's a diagnostic device for looking at the retina, for looking at the eye. And we have staff that are engaged in medical device development and rehabilitation science. And we have staff who are engaged in cell and tissue engineering.
The staff is so friendly and they are expertise in their field.
The department is well run and staff are nice. The facilities are great.
We've been kind of welcomed right into the department, and the lecturers are all really helpful.
I think it's a fabulous discipline. It's making a difference to folks who have a real need, and that's exciting. It's very positive in every way.
Well, that gives you a bit of a background to the department. You saw lots of images of students in both biomedical engineering and prosthetics and orthotics hard at work. What I want to say is that these two disciplines at University of Strathclyde, we are one department, and that's quite a rare thing within the UK, that we are a standalone biomedical engineering department. We're very large compared to lots of other places. So we have all close to 30 academic and teaching staff involved in delivering these undergraduate courses. And that allows us to have a really good breadth and depth of subjects that we can deliver. And because biomedical engineering is such a large and wide discipline, we are able to cover the vast majority of it. All of our staff are research active, and we consider ourselves to be a very research intensive university. And in your fourth year, you will do projects. So, and those projects will be embedded in that research. So the next few slides will exemplify some of the cutting edge technologies that we are researching and that you could be active in your final years of one of our courses.
This is a new surgical robotics system which for the first time provides a unique capability to perform a curved tunneling inside the bone.
It fills up one of the spaces that at the moment exists in the hip surgery robotics.
It can access areas that are internal with great precision and accuracy. So for example, carrying out hip replacements, part of it involves accessing the proximal femur that you can't actually see.
Because the femoral shape is curved, it's not a straight on shape. If it was a straight shape, then a straight drill could go in and do the job, but the way the body is formed, the shape of the femur at the top is curved. So it needs something which can act in different dimensions but is also flexible. And this device is the first step to achieve that. It has got the flexibility required for the femoral shape. It has got the dimensions which can go into a femoral canal and prepare for that shape.
I think in terms of surgery, our aim is in orthopaedic surgery, which is what I do, we're striving to be as accurate as we possibly can, and it has been shown that accuracy and precision can increase function and increase clinical outcome. So I believe that the more precise and accurate we can be in using the technology we have available, and there's nothing like this currently available, so I think it can allow us to be more accurate in places we can't be as accurate as we currently are.
So I chose that video to show you because, well, first of all, it's really good, interesting medical robotics, but also the fact that we have, well, every single academic member of staff has close linkages with hospitals. In that video, you saw two consultant orthopaedic surgeons actively working in our laboratories, working with our members of staff, delivering solutions for healthcare problems. One of the next video I'd like to show is a piece of equipment that you will, if you study biomedical engineering, and also potentially if you study prosthetics and orthotics in your research project, is to, oh, sorry, my fault.
This
is a motion analysis system and a rehabilitation platform. At the bottom, you can see a platform, and this can rotate. You can walk downhill, you can walk uphill, you can either twist this on its side. You can see that there's a treadmill. It's a dual belt treadmill, so we can have the belts going at different speeds. We can stop one suddenly. We can sort of try and trip somebody up. You can see there's the person is walking in a 180-degree virtual environment, and that environment is interactive. So if you place markers on the body, the computer knows where your body is, and you can start playing rehabilitation games. In the example on the screen, we've got an able-bodied person who is walking on some small little stilts, and they're testing out some new prosthetic feet. So that's the example there. But this is really a rehabilitation platform where we design games to help people rehabilitate from conditions such as stroke, hip replacement, knee replacements, etc., to enhance their recovery. If we can work out what works on a platform such as this, then we can reduce that technology into a more manageable, something that you can take home to do, or something you can do in a hospital setting. So obviously not every hospital or every home can have such a wonderful setup that we have, but in this enables us to find out what works, and then we can distill down the essence of what works into a much smaller device. So that's it. It's called a Motec Karen, and the third year biomedical engineers get to use that in the biomechanics class. Not video based now, but on this slide you can see that staff in the biomedical engineering and prosthetics and orthotics are having real big impact. The newsworthy stuff. So this is BBC website on the 25th of September. We've got the woman on the left is Professor Trish Connolly from our department, and she is working out ways to extract information or blood molecules from newborn babies without the need of needles, which are highly problematic, very difficult to get into the right place. Mums and babies don't like them, and if there's a way to do it through the skin, then that's a much better solution, and she's very close on trialling what's going on something there. Damien Corrigan, the picture, the inset picture at the bottom, is making great strides in developing a test to diagnose sepsis very, very quickly. So you can take a quick blood supply, put it into the diagnostic electrodes, so a series of electrodes that he's invented, to get an earlier diagnosis of sepsis. And this is critical for the ability to potentially recover from this awful condition. We had two other members of staff. We've got Sylvie Coupeau on the left and Professor Stuart Reid on the right. They are involved in a project where if you have stem cells and you vibrate them in a very, very small, minute way, we call it nano-kicking. If you nano-kick these stem cells in a certain particular way, then we can get them to turn themselves into bone-making cells. And this is excellent and really it's a good step forward to help fight a debilitating disease of osteoporosis, which is a bone brittle disease, so where you lose bone. So if we can create bone in the test tube and put it back into the body, then we can restore bone mass and enable people to walk without fear of their joints fracturing. So that's just a few studies recently in the news, but every single member of staff is involved in high quality research. All that research feeds into our teaching and into our programs, and Strathclyde is ranked first in medical technology by the Complete University Guide, which we're very proud of. So what I'd like to do now is just take a little bit longer to talk about what's involved in each of the degrees. Back in 2012, when the biomedical engineering undergraduate degree was envisaged, it was important to sit down and really sort of think, what does a biomedical engineer need to be able to do? They need to understand the mechanics of the human body as an engineering machine. So therefore, they need to have good skills in mechanical engineering. They need to be able to develop diagnostic devices and instrumentation to read the body signals, the electrical signals going on in the human body as well. So they need a fundamental background in electrical engineering. Naturally, that's got to be tied together with anatomy, physiology and cell biology. And so this Venn diagram of where biomedical engineering sits was constructed, and it feeds into the curriculum that has been designed. So if you study biomedical engineering with us, you in the first couple of years, you'll get taught mechanical engineering with mechanical engineers. You will get taught electrical engineering by the electrical engineers. This is really important core engineering knowledge. I cannot underestimate the amount of engineering. It is an engineering degree, and electrical engineering makes a significant component of it. Some graduates coming into our degree have been taken aback, or some applicants coming into our degree are taken aback by the amount of electrical engineering involved. It is considerable. It's about a third of the course. That's all combined with anatomy, physiology and cell biology, and the Department of Biomedical Engineering teaches that biomedical science, contextualizing it to human health. So that's really the first 2 years, is we get the core engineering and life science classes. Okay, once that core knowledge is in, then we can start combining the engineering knowledge and the biomedical science knowledge. So we can combine the mechanics to investigate the mechanics of the human body. In addition, we can look at biomaterials and what sort of materials work well with the human body, why certain materials are used for hip implants and knee implants, etc. What sort of plastic tubing is important. Those are fundamental questions. If you're wanting to link together technologies with the human body, you need to make sure that they work together. So they're the sorts of things that you would study in year 3. Year 4 goes even more specialist. We look at specific instrumentation. We transfer all that electronic knowledge core and really apply it to the biomedical engineering sphere. You do a study called professional studies, where you learn what it's like to be a biomedical engineer. One of the core components of the 4th year is an individual project. You might be working on the Motec caring system. You could be in the laboratory with Damien Corrigan with his developing the next series of electrodes for his sepsis project. Those are the sorts of projects that we get our undergraduates to do. In year 5, and year 5 is for the MEng students only, and I'll come on to how you can get to MEng. We have a group project for the whole of the first semester. That is embedded it's a real world industry project. You'll be in a group of 4 or 5, and you will work with a company or the NHS on a real life project. And starting off and seeing it to completion and working with that with these external clients to meet their needs. That's accompanied with a project management to help you do that. And there are lots of other specialist biomedical engineering classes which link in with our postgraduate classes. So it could be tissue mechanics, it could be regenerative medicine and tissue engineering, it could be biomaterials, it could be, what else? Medical device regulations. Regulations are awash in this field, and we have excellent external people that come in and deliver regulations classes. So that's a bit of the course. To go from year 4 for year 5, what you need to be doing is to be averaging 60% in year 4 or be on course to get a 2-1, which is a classification of degree. If you're at that level, then you'll get invited to go on to the 5th year. For those that start off on the MEng, you've got to maintain that standard. Otherwise, if you're not at that standard, then after year 4, you're graduated with a bachelor's with honours. So that's the course of biomedical engineering. We are accredited by 3 institutions because of the mechanical nature and the electrical nature. We are accredited by the Institution of Mechanical Engineers and the Institution of Engineering and Technology. And we are also accredited by the Institute of Physics and Engineering Medicine and all 3 accredit us for the master's course for the academic fulfillment of the requirements of chartered engineer status. So if you go on and graduate with masters, then you satisfy all their academic requirements for chartered engineer status. We have plenty of international opportunities for external study, and hopefully in 3 years' time, when you get to the third year, there'll be everyone will be transferring around the world a little bit more than they are at the moment. We have students who have gone all around the world. Hong Kong, very popular. We actually have a departmental exchange program with the Hong Kong Polytechnic University, where we've got an agreement to transfer students for a semester. But you don't have to go on that departmental exchange program. Well, we have had lots of students go to the US, Australia, Canada. I've currently this year we've had 2 students at Nanyang Technological University in Singapore, one of the top universities in the world. So biomedical engineering allows you to go to many places around the globe in the third year on an exchange program, and I'll happy to give you more information on that. So if you do our degree, what career prospects do you have? There are 27,000 medical technology companies in Europe, approximately, and these figures may be a year or 2 out of date, but they're quite difficult to find because many of them are small. Okay, so 95% of them are called SMEs, which is less than 200 people in them. So actually, quite a large proportion of that 95% are actually much less and smaller than 50 people. So these are quite small companies. It's highly innovative, it's highly creative. People have a great idea, they bring it to market, and they do very, very well. One of the big industries might come in and buy them up, or they can grow and create new ideas and grow and grow and grow. So there's a lot of innovation in medical technology, and this list shows the number of patents applied for in 2017 in Europe, and medical technology tops that list. So it's a highly innovative, exciting area to work in. And we will be, our aim is to put you at the cutting edge of research and development, enabling you to get these research and development jobs in industry and also in academia. Across Europe, there's a large body of biomedical engineers. It's not the same volume as mechanical engineers or electrical engineers, but there's a considerable business all around Europe. When back in 2017, the total market share for medical devices was about 115 billion euros. It's the second largest market outside of the US. Of course, with our degree, you can go and work in the US and go work in Asia as well. Medical devices are required the world over. In these turbulent times, medical technology has been showing a good, steady growth, and obviously there's a dip in the financial crash after 2008. But since then, the market has been growing quite steadily at about 5% a year. So I'd like to think is that a degree in biomedical engineering gives you excellent career prospects. Let me talk about the BSc Prosthetics and Orthotics degree. Please bear in mind I'm the course director for biomedical engineering, but I can talk a little bit about the Prosthetics and Orthotics degree. So there are, the first couple of years in Prosthetics and Orthotics, you study 3 core subjects. Okay, the first one is Prosthetics and Orthotics Science. And this is really the knowledge to develop the sockets and the interaction between the prosthesis and the human body. And that knowledge gives you lots and lots of laboratories associated with that, lots of hands-on making sockets and making prostheses and interfacing and making orthoses and interfacing those with real life volunteer patients. You've got to underpin that with some good human biological sciences, and alongside the biomedical engineers, you will learn the anatomy and the physiology and the cell biology necessary for your discipline. You also need to be a bit of an engineer as well. So the principles of prosthetics and orthotics design is really the engineering behind the prostheses and orthoses. So these are all putting loads onto the body. So you've got to understand the impact of those loads on the body, but you've also got to understand the impact of the body on the prosthesis so they don't break and fail. So they're the three core components of prosthetics and orthotics. And they are taught in years 1, 2 and the first half of year 3, but on campus based in a specialist facility in the current building, which is just underneath the library. In years 3 and 4, there are 2 clinical placements, okay, 1 in prosthetics and 1 in orthotics. And these are, they're long placements, they're 4-month placements. And in that you practice all the skills and learn new skills that you have been, you'll be experienced in. The 4th year, you need an individual project, and it could, and the staff in the prosthetics, or to deliver the prosthetics and orthotics degree, have a wide variety of research interests, which you can apply your project to. And also there are some electives or option courses at the cutting edge of prosthetics and orthotics. Go back to the placements. These are potentially, or many are in Scotland, but that we are not limited with that. So you can potentially go to England, Ireland, Wales. We've had people go to Sweden and Norway on these placements as well. So there is a potential for international travel a little bit, but there's no exchange opportunities because the curriculum is so condensed. In terms of accreditation, after 4 years you graduate and you are immediately registered as a prosthetist and, oh, pardon me, that automatically went forward. You're immediately registered as a prosthetist and orthotist with the Health and Care Professions Council, or HCPC, enables you to work as in the NHS as a prosthetist and orthotist. And I mentioned there are only 2 courses in the UK in prosthetics and orthotics, and we are the only course with the top category of accreditation from the International Society of Prosthetics and Orthotics. So that's a bit about the BSc in prosthetics and orthotics. So we have a lot more information on our website, so please go to see that. We also have active Facebook and Twitter feeds. If you've got any questions, you can email me on the email below. What I'd like to do to finish is to say that right at the start, I introduced you to the Wolfson Centre and this building, which was constructed in the 1970s. That, over the last year and a bit, has been going under a considerably extensive refurbishment, and it will soon be coming. We'll soon be reoccupying it. And so I'd just like to end with the architect's vision of our new departmental home. Well, there you have it. I hope you found the presentation interesting. Thank you very much for listening. If you've got any questions, please get in contact with me, and I look forward to welcoming you to Strathclyde very soon.